Hello everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to start about UV-VIS spectroscopy. So what do you understand by UV-VIS? So UV, we all are aware of this term UV, that is ultraviolet, whereas VIS is equal to visible. So today we will going to study about what is ultraviolet visible spectroscopy. In the previous lecture we have already covered infrared spectroscopy. So today we will going to study about ultraviolet visible spectroscopy. So what do you understand by this term UV visible spectroscopy? So the ultraviolet visible spectroscopy, or also you can say it is a ultraviolet visible spectrophotometry, refers to the absorption spectroscopy or reflectance spectroscopy in the ultraviolet visible spectral region. Ultraviolet visible spectroscopy, it is an analytical method that can measure the analyte quantity depending on the amount of the light received by the analyte. So what does this spectroscopy means? So this spectroscopy, they are equipped with the visible as well as UV range. So here it is this type of analytical method or analytical technique, it is equipped with visible as well as the ultraviolet ranges of the spectrum. So because these are filled with the hydrogen, or you can say hydrogen for the UV light and tungsten for the visible light, because ultraviolet के लिए they are equipped with hydrogen, whereas visible के लिए they are equipped with tungsten. So they act as a light sources. So there are several model of spectrophotometer which have varying degree of sophistication. Therefore the sophistication type of colorimeter is known as spectrophotometer. So what you understand by this? Spectro means monochromatic light. Spectro means production by light sources of whole range of continuous wavelength. So in this spectrophotometer, the monochromatic light, they are passed through a prism, and this whole technique is based on a principle, on a law known as Lambert-Beer law. Okay, so in this type of chromatography analytical method, it is simply used to measure the analyte quantity depending upon how much amount the analyte is receiving. Very easy. Means this type of analytical method, what they are doing, because they are equipped with two things. First is ultraviolet and second is the visible. So ultraviolet, it is equipped with the help of hydrogen gas, whereas for visible they have tungsten. So both tungsten here they are used as a light sources, and this type of analytical method, they are basically used to measure the analyte quantity. So how much analyte should be there means the quantity of analyte, they are directly depend upon the amount of light sources that are received by the analyte. Means what, how much light is amount is received by the analyte. Now moving to the next, it is the diagram, or you can say instrumentation of ultraviolet visible spectroscopy. So it have a light source. So then a light source, they will emit certain types of light. Then it is a wavelength sector. Again the light is passed through the sample. Okay, then it is detected by a detector because of the detector. Then the electric current and is used to produce the computer for signal processing and output. So now we will going to discuss about the principle of UV visible light spectroscopy. As I have already told you that this type of analytical technique, it is based on which law? I'm just writing here, Lambert Beer law. Okay, so the principle of UV visible light is based on Lambert Beard law. Okay, so UV visible spectroscopy is a quantitative technique that is used in analytical chemistry to measure the amount of light observed by the substances. Okay, so this point is very important, that UV visible spectroscopy, it is a qualitative technique. Why? Because it is just measuring the quality of the quantity of the analyte. So that is the reason it is known as the quantitative technique that is used in the analytical chemistry. Why they are used? Just to measure the amount of light that are observed by us substances. So in this, when the light falls on the substances, means whenever, if you can refer this diagram, when the light is fall on the sample, can you see? When the light is falling on the sample or a substance, you can say, it observe, because certain amount of light will be observed na, and a certain amount of light it will reflect. So it observe and reflect certain amount of radiation. So as the light passes through the sample, so as you can see, as the light passes, this light is passing through the sample, some amount it will observe, some amount of light it will reflect. So the amount of radiation that is observed by these substances is the difference between the incident radiation and the transmission radiation. So this point line is again very important, as you can see that the amount of light, amount of radiation, you can say, this color is, I think it is, so the amount of radiation that is observed by these substances is equal to the difference between the incident light and the transmitted radiation. So amount of observed radiation that is observed by the substance, how is it? So it is the difference between the IO, that is incident radiation, and the transmitted radiation. So the amount of radiation that is observed is called absorbance. Means, of course, the amount of radiation that are observed is known as absorbance, and the amount of light that is transmitted is known as transmittance, which is the fraction of I by IO. I here is a transmitted radiation and IO is a absorbance, indicating the amount of light that is passed through the sample. So as you can check here, so this the amount of radiation is which is observed is known as absorbance, which is transmitted is known as transmittance, which is the fraction of I by IO, where I is the transmittance, okay, transmitted radiation, whereas IO is equal to the incident radiation. Now moving to the next, that is what is the formula for the transmittance. So transmittance is equal to I upper fraction IO, I against transmittance radiation, and whereas IO is the absorbance radiation. So again I am just writing it here, or you can note it down somewhere. I refers to the transmission radiation. I'm just writing it in a short radiation, and IO is a absorbance radiation. So the amount that the substance is absorbing and the amount of radiation that a substance is emitting or reflecting. Okay, now moving to the next, that is absorbance is equal to A. A for absorbance, A stands for absorbance. A is equals to log 10 IO slash fraction means I, that is equal to log 10 1 slash t is equals to minus log 10 t. So this formula is very important whenever you are just studying about Beer-Lambert law. So according to the Beer-Lambert law, because the principle it depends upon which law, Beer-Lambert law. So according to the Beer-Lambert law, the absorbance of solution, that is containing the amount is directly proportional to the concentration of the absorbing species and the path length. So according to Beer-Lambert law, firstly let us understand what do you understand by Lambert law and what you understand by Beer law. So first of all we will going to study about the Lambert law, because this is the combination of the two, that is Lambert Beer law. So what do you understand by the Lambert law? Okay, so Lambert law. Okay, so Lambert law states that the amount of light state that the amount of light which is observed is directly proportional to the length or thickness of the solution. Means the amount of light, जितनी light observe कर रहा है एक substances, that is completely, or you can say directly proportional to the length or thickness of the solution. So you can say that A is absorbance, A is equals to log 10 IO upon I B. Okay, up here IO, we all know that IO is a intensity of incident light, whereas I is the intensity of the transmitted light, that I have already told you in the previous slide. Here E stands for the molar absorbance coefficient. So this is something new. What does E refers to? The E refers to the molar absorbance coefficient. Okay, coefficient, whereas C refers to the concentration of solute. Okay, that I will explain later. Whereas L here is stands for the length of thickness of liquid. Okay, so this is the Lambert law, means the amount of light that is observed is directly proportional to the length or thickness of the solution, whereas the Beer law states that the amount of light that is observed is again directly proportional to the here I am writing about the Beer law. So according to the Beer law, the amount of light or you can say the amount of light that is observed is directly proportional to the concentration of the solute in the solution. In Lambert, it is depending upon directly proportional to the thickness or length of the solution. Here they are directly proportional to the solute that are present in the solution. So this law is given by log 10, that is IO upon I EBC. Here again E is the molar constant, absorbance coefficient, whereas B is refers to the, sorry, it's not B, it's into and C here it is referring to the concentration of the solution. Again B is the thickness, C is the concentration of the solute. So when you combine these two, that is Lambert and Beer law, so it states that if you are combining the two law, states that the given at the given wavelength, the fraction of incident light that is observed, or you can say observed by the solution, is related to the length of absorbing medium as well as the concentration, because in the Lambert it is saying it is directly proportional to the length or thickness, and in the second Beer law it is saying the concentration. So when you are combining the two, so now it is depending directly proportional to the absorbing medium, length of the absorbing medium, as well as the second is the concentration of the solute in the medium. So this is the Beard-Lambert law. So the that we have already discussed. So again I am just writing the whole law of Beard-Lambert law. So according to the Beard-Lambert law, sorry, I'm just again I'm saying Beard-Lambert's law. It's Lambert-Beard law. Lambert-Beard law. Okay, ILBL because of the less space. So what does this law states? A is equals to log 10, that is IO upon I, is equal to EC is equal to ECI. Okay, ECI. So what does ECI? E is equals to IO is a intensity of the incident ray upon the intensity of the transmitted rays. Then they are directly proportional to the length of the absorbing medium and as well as the concentration of the solute in the medium. So that we have written here. Okay, now moving to the next, that is the instrumentation of the UV visible spectroscopy. As you can see, the instrumentation of the UV visible spectroscopy is known as UV visible spectrophotometer. So the spectrophotometer has certain few key components. The first is the light source, as you can see. Okay, second is a dispensation device, or you can say monochromator. Okay, that is known as the wavelength sector. Then they have a sample, then again they have a detector, and of course at the last they have a computer for signaling. So the light source, what does the use of the light source? So the purpose of the light source is here to emit the broadband electromagnetic radiation across the UV visible spectrum. Okay, now the dispersion device, or you can say the monochromator, it is a diffraction grating that separate the radiation into its component wavelength. So that is the work of this wavelength sector. Then again the next is the sample area. So the radiation interacts with the sample as it passes through the reflects off. Then at last the detector, it measures the reflected or transmitted rays radiation intensity. Okay, so this is the whole setup. So the measurement is done by placing how it take place. This is again very important, means how it is taking place. So if you can see, the measurement here is done by placing the sample in the sample compartment. So how the measurement take place? So you put the sample into the sample compartment. Then what you do, you take a liquid sample and you hold that liquid sample in a rectangular holder, and this rectangular holder should be made up of glass, quartz, plastic, or that is known as curvette. So the standard curvette have a 10 mm path length and allow easy transmission of radiation. So the curvette should be made up of glass or quartz or plastic, but it should be held in a rectangular manner. And the length of the carvet, if you talk about the standard carvet, so if you are taking the standard carvet, so the length should be of 10 path length. And so this length, they allow easy transmission of the ultraviolet radiation. Then the sample is placed in the path of the radiation. Now the sample, you put the sample in the path of the radiation. So as the beam from the monochromator passes through the sample and it goes to the detector. Now this spectrophotometer, what they do, they compares the light intensity of the incident radiation IO before passing through the sample and intensity of the transmission radiation, that we have already discussed in our previous slide, where we are talking about how this phenomena take place. Okay, so that passes through the sample and present the absorbance value, and the absorbance value is given by A, that is A is equals to log 10 IO upon I. Okay, that is equal to ECB here, where E is the molar concentration of molar absorbance coefficient, where B is the length or thickness you can say, and C is the concentration of solute. Now after that, let us talk about the applications of Beard-Lambert law. So what is the sorry, not Beard-Lambert law, what is the application of this spectrophotometer? So if you talk about the application, so it is very useful for both the quantitative as well as the qualitative estimation of macromolecules such as nucleic acid, proteins, pigments, etc. Even the colorless substances like sugar, or you take amino acid, metal ions, they can be estimated after reacting them and producing a colored derivatives. So it has a very huge applications. So let us discuss each application one by one. So UV visible spectroscopy is widely used to determine the chemical as well as the physical properties of the substances. So they are used in determination of both the chemical as well as the physical properties of the substances. Okay, so this makes it a very useful analytical technique. Why? Because it is covering both chemical as well as the physical property of any substances. So it is used for the identification of molecules in the samples. Whenever you want to identify the molecules that are present in the sample, you can use this type of analytical technique. Now the second is determining the concentration of compound in a sample. So whenever you want to determine the concentration of a compound in a sample, so you can use this analytical technique. Then again, it will help in determining the purity, concentration of biological samples that contain DNA or RNA. It finds application in characterizing the rate of chemical reaction. So these are certain applications that is used by with the help of UV visible spectroscopy. So one of the very important application that I am just writing it here, you can note it down here. So because of this UV visible spectrometry, it is very evident, or you can, it is very useful technique whenever you want to find or estimate the colorless substances. Even the colorless substances, so what are the are the colorless substances like sugar, amino acid, metal ions. So they can also be estimated after reacting them and producing the colored derivative. So this can also be estimated with the help of a spectrophotometer. Okay, so it has a very huge applications. Now moving to the advantages and disadvantages of this technique. So whenever you are talking about the advantages, so this method is a non-destructive, so that the sample can be reused. So here you are using you can use the sample again. You can reuse the sample, you can say. How? Because why? Because this method is not non-destructive. So this technique is very fairly simple and can be used easily. No prior training is required necessary. So again, it is it is saving your money. Okay, so because this is very simple and you do not require any training before handling this technique, so the measurement can be done in the short span of time. So again, time because this technique is taking very less time, so the measurement can be done very easily or very in a very short period of time. So help easy integration into the experiment. So data analysis is simple and required less processing. Instrumentation is relatively inexpensive and can be produced easily in the laboratory. So in short, I can say it is a very simple, reliable, fast, as well as very cost effective technique, and any one can handle this technique. Why? Because this technique is not requiring any prior training. So these are certain advantages that are related to this analytical method. Now again, what are the disadvantages? So real instruments are not always perfect, hence stray light may interfere with the measurement. Scattering of light due to the bubbles or undissolved solid particle in the sample solution causes measurement error. So these are certain disadvantages. Again, Beard-Lambert law is only obeyed when a single absorbing species is present in the solution. Okay, a sample if containing the multiple absorbing species, so this law cannot be help in determination of concentration, okay, using the absorbance. So this is again the disadvantages. It can only work with a single absorbing species. If you contain a multiple absorbing species, so this technique would not help, okay, could not determine the concentration using the absorbance. Then improper orientation of sample or holder or misalignment can be enable error in the measurement. So these are certain disadvantages that is related to this technique. So that brings to the end of the lecture. I hope you have understood the lecture. If you have any doubt, any query, you can leave your queries in the comment section below. In the next lecture, I'll be answering the queries. Please don't student follow ITLS Academy on this different portals like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn. You can also subscribe ITLS Academy, and you can visit our website, that is www.itlsacademy.com. This is our helpline number, so you can simply call on this number and get updated. So thank you for watching. Please do like, share and subscribe, and yes student, don't forget to press the bell icon to get more update related to this lecture. So at last, if you have any queries related to any of the courses you want to join, so you can simply call on this number, that is 7080833450, and you can get updated of any courses you want to join. So thank you once again. Thank you.